All right, here we're going to look a little bit at switch operation and virtual local area networks, or VLANs. So right now this switch, let's say it's out of the box, default config, everything's in VLAN 1 because it is by default. All interfaces are in VLAN 1. Right? PC 1 wants to send something to PC 4. As that packet comes in, so let's say our table hasn't been built yet. You see the table right now as it's completed, but let's assume the MAC address or CAM table hasn't been built yet. So as the frame comes into PC1, or I'm sorry, as the frame comes from PC1 into switch 1, switch 1 sees the source MAC address as all A's in this example, and it came from FA01. So then it writes in its table, the MAC address of this device is this. Okay, so whenever I need to get to PC1 again, that's the MAC address. It's going to go through FA01, and it knows that it's on VLAN 1. Now what it needs to do is figure out, it doesn't have yet in its table where the destination MAC address is. In this case, all 4s, right, for our example of PC4. So what it will do then is broadcast the packet out or send the packet out all the interfaces within the same VLAN. And since this is default, all of these devices are in the same VLAN. So it broadcasts the packet out, all the interfaces except for the one it came in on. It will get a reply from PC4. When it gets that reply from PC4, it comes in on FA04, so now it knows, okay, this MAC address is on Fast Ethernet 04, and it's in VLAN 1, right? Now let's say we break it up into, or we configure VLANs, and then we assign those interfaces to certain VLANs, okay? So what VLANs will do is break up the broadcast domain, right? Make it smaller, because the traffic can't cross the VLAN without being routed. We'll talk a little more about how that works. So now PC3, say, wants to communicate. Actually, so right now, once we've put these in separate VLANs, PC1 actually can't, with just this layer 2 switch, can't communicate with PC4. Right? So somehow it has to. And we'll demonstrate that when we configure our VLANs, right? So now let's say, okay, we're not even worried about these two communicating anymore. Let's say that PC3 wants to communicate with PC4. Switch hasn't finished its table yet, right? PC3 sends its packet through FA05. Switch 1 writes on FA05, writes to its MAC address table or CAM table. It writes, and FA05 is this MAC address, right? Because when the packet comes in, it sees the source MAC address of all C's and coming in on FA05. Now it'll do the same thing. It's going to pretend, let's pretend for a moment that we didn't learn it yet. So let's say switch 1 doesn't know where the destination MAC address of all 4s is. It has to then broadcast it out. This time it will broadcast what always broadcasts out to all the devices in the same VLAN or the same broadcast domain. In this instance, what that means for us, because we created 2 VLANs, that the only device that will get, or the only interface that will get that broadcast packet is FA04, because it's the only other one that's in the same VLAN as PC3. And remember, we broadcast out all the interfaces except for the one it came in on. Okay, so VLANs are going to help us break up that broadcast domain. And there's a lot of other neat features, but it certainly helps if there's a problem, helps separate people and devices, I should say. Right, so now instead of everyone getting the broadcast that they certainly don't all need, so we mitigate some unnecessary traffic this way. In this instance, the only one that will get it is PC4, and then he'll respond, and the switch can then write to its MAC address table on FA04, this device or this MAC address, and it's in VLAN 40. We'll also keep track of VLANs. VLANs segment a switch into separate broadcast domains, right? And we can't cross VLANs. We can, with trunks, we can pass multiple VLANs across a link, but we're not going to cross from, say, VLAN 10 to VLAN 20 without routing. Okay, and remember, routers don't, by default, forward broadcast, so it's kind of a neat. You can kind of visualize that each of our VLANs is going to be a separate broadcast domain. Generally, we assign a different subnet. We would assign a different subnet for each VLAN. The VLANs that can be configured and the number of VLANs depend upon the platform. Okay, but as a whole, we have an overall range of 1 to 4094. I should call that probably the usable range. 0 and 4095 are reserved. 1 is the default VLAN, so VLAN 1 is the default VLAN. When you clear everything off or when you buy a switch and you take it out of the box, VLAN 1 will be configured and all the interfaces will be in VLAN 1. VLANs 2 to 1001 are standard Ethernet VLANs. We can modify and add and delete those, which is what we'll do. And then 1002 to 1005 are reserved for use for token ring and FTDI, and they can't be deleted. So by default, VLAN 1 and VLANs 1002 to 1005 will be on our switch always, and we can't get rid of those. Okay, we can choose not to use them, and in fact, we do say as we go through some of the security stuff, not to use VLAN 1 for anything because everybody knows that that's the default. So we don't want to do that. And then we have our extended Ethernet VLANs of 1025 to 4094. I don't find that we use them a lot. Maybe for private VLANs, but I haven't personally used them a lot. Generally, the 2 to 1001 works pretty good. And then we have another option. So we could say we have what we call our voice VLAN. So every interface, I bet you I'll probably end up going over this twice. Sorry. Every interface is assigned to VLAN, even if you don't do it, right? Because by default, it's assigned to VLAN 1. Okay. If there is no voice VLAN created, then only an interface can only be assigned to one VLAN, right? So what we can do is we can configure an interface to be in VLAN 10. Okay, and then if we go back through and issue the same command and do switch port access VLAN 20, it overwrites the VLAN 10. It can only belong to that one. I'm going to call it one data, even though it could be used for data, voice, and video. I'm going to call it one data VLAN. We can have two VLANs only if the second one is a voice VLAN. Okay, so voice VLANs, I can configure them on my access port to go ahead and separate my data and my voice, almost like a voice infrastructure overlay in a sense, so I can have VLAN 10 and then I can have voice VLAN 11. That's the only way to have two VLANs on there. Without a voice VLAN, there's only going to be obviously one. We have what we call two VLAN topologies. I can either do end-to-end, which means that the VLANs will span the whole layer 2 switch infrastructure. We used to do that when we had 80% of our traffic. We'd say 80% of your traffic is local. So most of the things I send or receive are in the same VLAN that I'm in, and I don't need to leave the layer 2 infrastructure. And then, and then we would say, about 20% needs to go outside of that broadcast domain or needs to go to some remote location. When we do end-to-end VLANs, we could group users by function rather than physical location. We find now that we really don't do that as much, and I don't even think it's generally recommended practice anymore to have the VLAN span the whole layer 2 infrastructure, especially with how inexpensive routing on a switch in particular is right now. It's fast, it's inexpensive, and we can have a lot more control and keep things localized. So then we do, right, our local, so our other topology is a local, right, and that will span only part of the switch network, and then we'll go ahead and we'll route those VLANs at aggregation points. Usually the distribution we could route at the core layer, right? And then that's the opposite of what we say the 80-20 rule. It's kind of the 20-80 rule, right? The traffic, 20% of the traffic stays local, so a small part of it, and then 80% of my traffic or more needs to go off of that broadcast domain or needs to go to some sort of remote area. So we have the N10 and we have the local VLAN topologies. So how do we go about configuring VLANs and breaking up our broadcast domains and making everything nice and clean? And I will demonstrate, but let's just go over the commands real quick. So just to configure a VLAN, we'll go into global config and we'll use the command VLAN and then the number of the VLAN we want to create, and then we'll do a name if we want to name it, and then go ahead and name that VLAN, and we'll type exit. One thing to note is until you type exit, so if you hit something else, it's not going to work. Until you type exit, that VLAN actually isn't committed or saved. Then what we want to do is we we could create VLANs, but we want to assign things to VLANs. So in our previous part where we configured VLAN 40, in order for those hosts to belong to VLAN 40, the interface that they're connected to needs to be in VLAN 40. So we do a switch port mode access to say, hey, this is an access port, not a trunk port. Talk about that more probably later when we talk about trunks. We'll do switch port access VLAN and the number we want that interface to belong to. And then remember earlier I said we could also overlay kind of our voice infrastructure so we can separate our voice from our data. So then we would do switch port voice VLAN and that VLAN number. So let's go ahead and do that. Here's the topology I'm going to be working with. I'm going to set that up just for a minute there. If you want to write it down, you can. I'll probably be using that for the next few instructional pieces. So I have two switches. They're directly connected to each other on gigabit 1 and 2. And then I've got 3 hosts. And what I actually did, instead of setting up actual computers or anything, or VM virtual machines or anything, what I did is I just configured routers. And it doesn't matter, you won't see it, there's no routing happening. Basically what you can do is you can configure a router, tell it to not do IP routing, put an IP address on it, and then it just acts as a dumb host. It doesn't do any routing or anything like that. And so that's when you see, you'll notice you'll see the CLI and you're like, huh, that doesn't look like a Windows machine. No big deal. All they're there for is to point out that I have end devices connected to these switches. They'll start out everything in VLAN 1, including these interfaces connecting between the switches. They're in VLAN 1 also. So I should be able to ping everywhere. Okay? All right, so let's go ahead and do that. I'm going to first bring over host 1, and I'm going to go through and I'm going to ping host 1, host 2, and host 3. Oh, and I see it's not on there, so I'll make sure that I do that for next time. Yep, because I see that the IP addresses for those hosts aren't on there. You know what, I'll just go ahead and write them in real quick. So it should be 192.168.1.1. And then this guy down here will be 192.168.1.2. And over here he's 192.168.1.3. So you'll see they're in the same subnet right now. And they're also all in VLAN 1 by default, right? Okay. So then let's go ahead and demonstrate configuring VLANs and how they're going to react. All right, so let's go into our host 1 and go ahead and ping all our other hosts. We should see that it works because they're all in the same VLAN and they're all in the same subnet, right? Oh, 192.168.1.2 would be host 2. And if we up arrow and go back, 1.3 will be host 3. Oh, would be helpful if I moved that out of your way, wouldn't it? Okay, so everything works fine. Now we're going to go ahead and we're going to go into our switch and are going to configure our VLANs. Let's go ahead and put let's put PC1 into VLAN 10, and then we'll move over to switch 2 and put host 3 into VLAN 10 also. Okay. All right, so let's go ahead and we'll create our VLAN, and then let's name it HR1. Okay. Go to global config, VLAN 10. Come on, hit enter. All right, notice here, like I said, if you do show VLAN brief, it won't show up. All our default VLANs are showing up though, so that's good, right? Anyway, we'll exit out. Now I should have hit end maybe. Let's go back one more instead of using the do. So let's do show VLAN brief. And now our VLAN 10 is there, but nothing's assigned to it. So now we want to go ahead and we want to assign PC, what do we say? PC1 was going to be in VLAN 10, or host 1, let's call it that. So host 1 is connected to gig 03. So then we need to go into gig 03, do switch port, tell it it's an access port first, and then switch port access VLAN 10. Ah, shucks, before I did that, oh, we pinged the host, that's right. Okay, so now let's see, I'll go back over to switch 2, right? And we'll put PC3 on there also. All right, so on switch 2, host 3 is also on gig 3 on switch 2, so we'll go ahead and do the same thing, remember. Now, one of the things I just wanted you to know is I'm going to do it a little bit differently. The VLAN will get created if it's not when you do the switch port access command. And so, shucks, I went too far. And let's do a show VLAN brief. You'll notice VLAN 10's not here. The only difference is I can't name it. I can't go into VLAN configuration. It just creates it. So if I want it named like I did in the last one, then I have to create the VLAN and name it. So I'm just going to show you a different way. I'm not going to name it this time. Normally, obviously, for consistency, I would have named it HR1 so that no matter which switch I go on, I know that VLAN 10 is going to HR1. But this time, instead, we're going to go right into the interface, right? I just did a tab completion. I'm sorry, I'm trying to type everything through, but a lot of things are just automatic. Switch port mode access, switch port access VLAN 10. And then notice that it will, since it doesn't exist, it's going to create that VLAN. And let's go back and then do show VLAN brief. Whoops. Brief would be better. And you can see now VLAN 10 was created with the default name, and it's just the VLAN and the number of the VLAN, and gig 03. Now I'd have to ask, now at this point, should host 1 be able to ping host 3? No, it shouldn't, because we didn't create trunks. The issue is, let's look at that real quick. So the issue is right now that host 1, right? Let's change colors here. Ooh, that's not a very good color. Host 1 now, he's in VLAN 10, right? Host 3 is also in VLAN 10, so theoretically, they should be able to communicate with each other. However, right now, both of these interfaces are in VLAN 1. Right? What's interesting is in some platforms, and I'm going to talk about this more when we do trunking, so let's not get too lost in the weeds, but in some platforms, these will automatically trunk straight out of the box default configuration. And I'll explain that when we get to trunking right now. Or I'll explain that when we get to trunking. Right now, just know now these guys can't communicate because this is only passing VLAN 1, and they're only in VLAN 1. I can't cross from 10 to 1 and then to 10 again without a router, remember? So that's not going to work, right? A couple other things. I'm sure I'm going to miss some things, so don't call me out on it, but let's look at just a couple other things we can do. Now you can create multiple VLANs at once just by listing them, 10, 20. It'll create 10 and 20. You could do, 21 to 30. Right, that should create all of them. So this should create VLAN 10, 20, 21, 22, 23, all the way to 30. Okay. Notice here the only difference is I can't name them all the same names. So if I try to do the name command and I give it a name, name example, enter, it'll tell me that we can't modify names for multiple VLANs. We exit out though, our VLANs will be created. So if we show VLAN brief, you'll see that in our 1 command, we did in fact create VLAN 10, 20, and then 21 through 30. So something simple. We have the many broadcast domains. If we do a show, let's exit back one. Let's do a show MAC address table. Gotta try to remember to keep my mouse out of your way. Whoops, and I put do in front of it. We're not at global config, you don't need the do part of the command. I actually went back to where I wanted to go. And then I'll see, too, that now VLAN 10 is mapped to my host that's connected to gigabit 3. Okay. All right. So that's it for this one. If you have any questions, let me know.